Hello friends, welcome. My name is Rahul Singh and today we will be seeing the most important topic among the physical chemistry in itself. We say that this topic is very much important, with particulars which is related to the IT, JEE, NEET and whatever competitive exam we are going to exam we are going to compete with. So here the topic name itself, it is a electrochemistry. Okay, so the topic name, it is a electrochemistry. So before proceeding with this topic, okay, before proceeding with the topic, we have to clear certain few things that is very much important, like basics that we are going to use when we are going to study the electrochemistry part. Okay, so here first, in electrochemistry, whenever we start studying with the electrochemistry, we should know the basic terminology like redox reaction and the thermodynamics parts are there that we have to keep in mind. So redox reaction, what is exactly the meaning of a redox reaction, that we have to see. Redox reaction, these are the basic that we are going to require in this particular chapter. So redox reaction, it is nothing but that is a simultaneous process. It is a simultaneous process of oxidation and reduction. Oxidation and reduction. Simultaneous process. Oxidation and reduction. Now many students, they might confuse with oxidation and reduction. What exactly a oxidation and reduction process? So it is a generalized form that we are going to require over here. That is oxidation. It is nothing but, okay, oxidation, that is nothing but that the thing which we are going to require over here. Oxidation itself, it is nothing but loss of electron. Loss of electron. So what is electron? So in case of hydrogen, that most important terminology, we we have to treat hydrogen as electron also and hydrogen as a proton also. So in this terminology, loss of electron, it is nothing but loss of, or we can say that loss of hydrogen also, loss of hydrogen. But we are going to use that is a loss of electron itself. Okay. Now the next terminology, that is a reduction. What is exactly the meaning of reduction that we have to keep in mind? That is a gain of, that is nothing but gain of electron or gain of hydrogen, or gain of hydrogen, that we have to use this terminology. That's why I'm clearing the basic which we are going to require in this chapter. Okay, so this is the first basic that we have to keep in mind. What exactly is going to happen over here? So whenever we deal with electrochemistry, okay, whenever, like here we will start solving this one now. Like whenever we write for this electrochemistry, so first, in whenever we study electrochemistry, in chemistry, basically we just break the terminology. Okay, we just break the terminology. Electro, that is related to a electrical energy. Electro is related to a electrical energy, and chemistry, that is related to a chemical energy. It is related to a chemical energy. So from here we can clearly see that what exactly we are going to see. Basically, this is electrical energy and chemical energy. This is a combo. Okay. So in electrochemistry, we study the combination of electrical energy and chemical energy. So what exactly electrochemistry it is? So when we give the input of electrical energy, when we use electrical energy to convert it into chemical energy, so that particular terminology, it is called as a electrolytic reaction or electrolytic cell. We refer this as a electrolytic cell or a electrolytic reaction. Okay, and when we convert chemical energy into electrical energy, this part is referred as a galvanic. This part is referred as a galvanic cell or voltaic cell. Okay, voltaic cell. So what exactly a electrochemistry is? That is a electrochemistry. When we study, basically it deals with the interconversion of electrical energy or chemical energy. Vice versa, we can use both. We can use both the terminology. Okay, that is interconversion of chemical energy into electrical energy over here. Okay, or vice versa, we can use. And basically these interaction, this is very much important. These interactions occurs at boundaries between electrolyte. Electrolyte is nothing but the solution basically. Okay, so we are going to study about this particular part, electrolyte and the electrode, the current carrying like whatever current carrying instrument, or we can say a metal that basically we use to carry a current over here. Electrolyte and electrode that is deep in it. Okay, deep in its solution, deep in it. Okay, so all these interconversion are, we refer this particular, this all over the conversion is there. So this whole conversion from like chemical to electrical, electrical to chemical, this whole conversion, this whole part, like when we use electrical input to get chemical output, that is electrolytic cell. And if we are giving the input of chemical energy to electrical energy, this output, this whole scenario, this conversion, it is referred as a electrochemical cell. This is referred as a electrochemical cell. Electrochemical cell. So in this, basically in this chapter, we are going to study, like here we have seen main two parts, that is this electrochemical cell that involves galvanic cell, voltaic cell, or it is called as a voltaic cell or electrolytic cell. There is a so this is the part that we have to focus on, and these are the basic, like redox reaction, oxidation reduction. This part we have to keep in mind. Okay, so this is first we are going to see over here. And then before starting this chapter, generally students do the mistake, like when we say the electrode, there are two types of electrode generally. Electrodes are two types. That is, first one is a cathode and another one is an anode. So generally student, how they remember this part, that is anode is a positive and cathode it is as a negative. So but in this chapter, what we are going to see, what we have to remember, that we are not supposed to remember in this part. Okay, so always whenever we look at the cathode, okay, whenever we are going to name the particular electrode as a cathode, we have to see that is reduction is occurring over there. Reduction should be there. Reduction occurs over there. Reduction occurs at that particular part. Reduction means gain of electron. Gain of electron will be taking place. And when we deal with anode, okay, when we are going to see the anode part, that is nothing but oxidation is occurring. Okay, oxidation occurs. This is our main part. Oxidation occurs means oxidation is nothing but that is a loss of electron. Loss of electron. And one more terminology that we are going to require over here, that is nothing but Gibbs free energy change, that we are going to study and like we must have already studied in thermodynamic part. So here Gibbs free energy change, many students do the confusion in between that. Gibbs free energy change, Gibbs free energy change, that is represented as delta G. Okay, and there is one more terminology when we study the thermodynamic, that is the spontaneous and non-spontaneous. So spontaneous or non-spontaneous means non-spontaneous. When we talk about non-spontaneous, that is, it is not automatic. Okay, it is not automatic. Means externally we have to give a support to this particular thing. This is a not automatic reaction. This is non-spontaneous means it is not going to happen by itself. Spontaneous means it is going to take place by itself. But here non-spontaneous means we have to give external support to that particular thing. And Gibbs free energy change, when we talk about like if we are giving certain energy to someone, like suppose if I am having like suppose I'm having a 50 kilojoules of energy, 50 kilojoules of energy to do a certain work, and this much energy is required to perform that particular work. And if I'm getting a support of my brother or an elder brother in that particular manner, so he's giving me support of another 50 kilojoule. So my energy is saved over here. My energy is going to saved in this terminology. So my brother is going to support me to do this particular work. So my energy will be positive in that part. So many students do the confusion what exactly the Gibbs free energy. Basically Gibbs free energy, that is delta G, it is equal to delta H minus T delta S. So in this non-spontaneous terminology, like not automatic, I'm not going to do that particular work. I'm taking a help of my brother. So he'll be giving me energy. So that particular my energy, my self energy, like whatever energy I'm using over here, it will be saved. So that will be a positive part. Okay. So we are going to study this terminology over here. So here, first in electrochemistry, like we have seen that three parts we are going to study over here. Okay. First part, that is nothing but a electrolytic, that is a electrolytic cell. So in this particular manner, we use input. We use an input as a electrical energy as an input, and in output we use this as a chemical energy. So we as an output we get, that is a chemical energy we get. That is a hypothetical terminology because it is not possible exactly to get. So but we are going to study about this part. Second is nothing but galvanic cell. In this chapter we are going to study a galvanic cell. So galvanic cell, it is nothing but the input part over here. Okay, the input part in this particular cell will be of chemical energy. Okay, we are going to do the chemical reaction, and as an output, we are going to get a electrical energy. That is very much important part. That is it is used in this. Basically, this whole chapter, it is a application oriented chapter. So in any competitive exam, they are going to ask many, like in 2008 and 2009 advance also, they ask two expression from this chapter. In every year, there are questions which are based on electrolytic, like electrochemistry itself. There are very nice questions. We are going to see one by one, all the questions will be there. So in galvanic cell, we are going to do, see this particular terminology. And after that, the third part that is very much important, that is a conduction of solution. We are going to study about the conduction of solution. These three parts, these are very much important. Conduction means in our household appliances, electrical appliances, all the appliances, they use electrical energy. The flow of electrical energy will be there. That's why appliances are working. So conduction of solution is generally done by the flow of electron. So flow of charge or ions. We are going to study about that particular thing, flow of charge or ions. So these are the three important parts of our electrochemistry terminology. So what we have to remember over here, that is what is a cathode, what is a anode. So cathode means reduction is occurring over there, and anode will be oxidation is occurring over there. And the basic terminologies we have seen, what is reduction, that is gain of electron will be there, and in oxidation, that is nothing but loss of electron is taking place. So Gibbs free energy, non-spontaneous, spontaneous, we are going to see that particular part, but we have to keep this example in mind to proceed for further things. So in the first part, we'll be dealing with here, the first part we are going to deal, that is a electrolytic cell. We are going to deal about the electrolytic cell. So in this particular part, we are dealing with electrolytic cell. So the first point that we have to keep in mind related to this electrolytic cell. So what is exactly the electrolytic cell? That is here interconversion, or we can say that the conversion of basically we have seen that input is about the electrical energy. Conversion of electrical energy into chemical energy. Okay, this is the first part that we have to keep in mind. In electrolytic cell, we do the input of electrical energy. Okay, input of electrical energy. Okay, second part is very much important. That is nothing but it is a non-spontaneous redox reaction. Non-spontaneous redox reaction. Redox means we have just studied about the redox. I have just cleared that basic terminology related to redox, that is alternate or simultaneously, that is oxidation is also taking place over there, and after oxidation there will be a reduction or vice versa. Both the processes are taking place, oxidation and reduction, and we are familiar with the oxidation, that is loss of electron, and reduction means gain of electron. So what is a non-spontaneous basically? So we have just seen the example, that is 50 kilojoule and the energy required to do the work. So whenever we have an input, here we are doing the input, we are providing means we are going to give that certain energy to that particular system. So it is non-automatic. It is not going to happen by itself. We are providing means we are additionally adding to that particular part. So due to this is non-spontaneous, means we are providing electrical energy to this particular thing. So due to this, that gives free energy change. Okay, we study this part in thermodynamic also. Gives free energy change, free energy change, that is delta G. In this scenario, as we are providing energy from outside, this will be positive. Okay, because the system itself, it is not going to use its energy. This is a mathematical expression for this. So certainly, like this is the energy related to, suppose we have a system over here, and this whole system has a total energy of delta H. Okay, and the work which is going to require the energy, that is T delta S. T delta S amount of energy we are required, but we get this energy from outside. Okay, this much, suppose T delta S will be 50 kilojoule. So this much amount of energy we are getting from outside. So this work done, it is not done by the system. So system is not doing any kind of work over here. So this plus 60 will be saved for the system because it is getting it from the outside. So this will be delta G. So delta G will be positive in this scenario. So ultimately, when spontaneous reaction will be there, so yes, we can say in that particular part, we use delta G as a negative terminology. Okay, so here Now we have to take, to understand this process, suppose we have taken one beaker over here, and in this beaker we are taking a electrolytic solution. We are taking what? Electrolytic solution. Okay, electrolytic solution means which electrolytes. Electrolyte means positive and negative ions. Okay, this simplified terminology that we have to remember means positive and negative will be there. Positive and negative ions will be there. So I am just referring them as a C and A. This solution name as a Ca. C stands for cation. I am taking C for cation, means C will be in a positive form and A as a negative. So this whole C plus and A minus will be there inside the solution. They are spread over the solution. Okay, and here this electrolytic solution. So many students do the confusion. What exactly the meaning of electrolytic solution? Here electrolytic solution is there. So what is electrolytic solution? Electrolytic solution, as I mentioned over here, ions will be there. So there will be a formation of a ionic bond. Okay, ionic bond means complete transfer of charge will be there. Complete transfer of charges. Okay, so this is what we have to remember. Complete transfer will be there, and to now here to conduct the electricity, like we are going to, it is a non-spontaneous and we are using an input of electrical energy. So here we are going to place electrode that is made up of, it is a metal basically. Okay, so this plates, these electrode are nothing but we name them as, this is our electrode. Okay, both the electrodes are there, and we are using a platinum electrode. We are using over here a platinum electrode, which itself, it is a inert, means it is not going to affect the solution. Inert electrode is there, so it is not going to affect this particular solution over here. And now here we are going to provide electricity. Okay, we are going to provide electricity in this scenario. So we know that we use this terminology. This is our negative terminal and this will be positive terminal. Simplified. This is simplified, that we have taken one beaker, and in that particular beaker we have taken electrolytic solution. And electrolytic solution is nothing but the solution having an ionic bond. Ionic bond means complete transfer of charges will be there. So, and to conduct the electricity, we are using electrodes, which are made up of platinum, and platinum generally it is a inert electrode. So when we supply energy, okay, when energy flows, this negative part will fill up a negative charge over here, and positive charge will abstract all the electron, so it will become a positive toward this side. So here we have a two terminals now. So how this reaction is going to proceed, that is very much important. If you understand this part, so this Ca is over there. So whenever we flow the energy into that particular Ca, equilibrium will be there, and we get C plus and A minus charges. So what exactly happening over here? I will suggest you one more thing, that is, whenever we are going to write the reaction over here, so always start with the positive part. Always start with the positive terminal. So because it will give us an idea. Okay, why I'm writing this one, you will get the whole idea about this one. That is, at positive terminal, always start with the positive. Okay, at positive terminal, what is going to happen? Why we call this positive terminal as cathode or anode? We will see that particular thing over here. At positive terminal, what is happening over here? This whole electrode, it is in a positive form, so it is going to attract the negative side. So what will happen? A is as a negative part, so it is going to like already we have seen, that is, it is basically here interaction occurs at the solution and the boundary of the electrode. We have already written the that particular definition. So A negative, it is going to give its electron to that particular electrode. So one electron will be given and it will convert to A. So what exactly happening over here? That is loss of electron. A is losing one electron over here. This is the left hand, means reactant part, and this is a product part. So A is going to lose electron. So what is the terminology we have used? That is, what is a cathode? Cathode means what? Means where reduction will be there, and for anode we are using a oxidation. Yes. So loss of electron means we refer this as a half oxidation reaction. We refer this as a half oxidation reaction. Okay. And then there will be one more reaction at negative terminal. At negative terminal. Here what is happening over here? Negative terminals this side. So C plus will be there. Which is going to accept the electrons. Okay, which is going to accept electron and converting to C itself. So gain of electron means we have seen, that is, it becomes half reduction reaction. Gain means reduction, so that's why it becomes reduction reaction. So as we have already given that that is oxidation means this will be our anode. For generally we always write anode first, that's why positive terminal at first, and this will be our cathode. So this terminology that we have to keep in mind, and when we solve this equation over here, one electron on right hand side is cancelled with one electron on left hand side. So this becomes A plus and A minus plus C plus, which is giving us A plus C. And this A minus and Ca, this will be C plus and A minus, it is nothing but our Ca, which is giving us A plus C. So this is a general idea behind electrolytic solution. So we can take electrolytic solution that is nothing but NaCl. Okay, NaCl means Na is positive in that particular thing and Cl is minus. So in this scenario we get Na plus half Cl2. So how it is going to react, this we are going to study in next lecture. So this is we have seen here today, that is how reaction proceed over here, how conversion takes place. So this is the whole idea behind today's lecture. I hope you have understood this particular thing, and please stay tuned. You will be getting all the recorded lecture as soon as we are going to proceed. So till then, keep on studying. Bye bye.